What's up, everybody? So we'll get started in a minute or two. I'll just repeat what we were talking about. So if you haven't joined the Slack, you can scan the QR code or it's that yellow link on the screen. And I'd recommend joining, obviously, to keep up with events, but also to join this channel that we made for this workshop. So if you have like technical setup questions, or even questions like about AWS later or the workshop later, if it's not done, like feel free to send in there and we'll address them as quickly as possible. What else? I sent a big block of links in the chat. I'll just copy paste it again, but they're also in the Slack. So those are like the first three are like things you can do right now while I'm about to go through this big presentation. And then the last thing's the actual workshop we'll go through. So yeah, it's 6:02. So we can go ahead and get started. If someone's late, I don't know. You guys can help people in the chat, all right? if people ask questions in the chat, I don't know. If you know something, let somebody know, all right? Cool. So first of all, welcome. If this is your first ACE event, that's hype. We're glad to have you here. We're going to kind of go over broadly cloud computing in general, and we're going to go at it from like a very intro perspective and then kind of throw a lot at you in terms of terms and stuff. Like what I want to say before we start is like, cloud computing is a whole giant niche of computer science. Like it can go on forever and there's like a whole lot of stuff there. So don't be like overwhelmed, especially if this is your first time doing something like this, if you're a freshman. So yeah, but we'll cover cloud computing broadly and then AWS itself and what AWS offers, I don't know, stuff like that. And then we'll actually go through the workshop. So hopefully we have at least 30 minutes, hopefully more like 45 for the workshop. But we'll see. Cool. And I think that's, oh yeah. So, and I didn't put a slide in here, but for me, so I've interned twice at Amazon and have had to do a whole bunch of stuff with AWS. And there's other people in here, I think, that have been at Amazon as well, potentially. So hopefully we'll have a good base of knowledge for how to use this stuff. Cool. So just real quick, just to get out of the way again, I sent those 3 links, which are prereqs. You need to have Git, you need to have an AWS account, and you need to set up the AWS CLI. So you can set that up right now while I talk, or if you're lazy, like just come back later. Keep following along, and you can always come back because it's all going to be recorded. So cool. Right. So first of all, we'll cover what cloud computing is. I can give you the dictionary definition and the actual one that makes sense. So using a network of remote servers hosted on the internet to store, manage, and process data rather than a local server or personal computer. So what you're doing is you're basically paying to use somebody else's computer. And that's to do a whole bunch of stuff, right? It's data processing, it's storage, it's any kind of business logic. You're basically paying to use somebody's computer remotely, right? So Amazon, for example, has these giant data centers all over the place, and there's 82 of them, I believe, in the world, and they look like this. But for the most part, when you're talking about major cloud providers, it's big data centers right here where you're paying to run out a small, tiny amount of computing space to do your business logic. Obviously, you can see here, this is a representation of the cloud, and we'll talk about application versus platform versus infrastructure as a service now, I think, right? All right, next slide. So from like a business perspective, it's pretty valuable to know why cloud computing is a great option. And it's something like going into an internship or something, it's really good to know. And also to just keep it in the back of your mind as you create stuff with AWS or some other cloud service. So there are a lot of benefits. Obviously availability for the most part, although I don't know if you guys have heard about like Facebook and other, I mean, that's not cloud, but AWS goes down sometimes, everybody goes down. So that's a thing. But also just reliability, really good processing speeds. Maintenance is a lot lower when you're paying AWS to do it. So for some instances, it makes a lot more sense to use cloud computing than to create your own in-house solution. But I think the biggest thing that you should keep in mind is that for cloud computing, it's a pay-as-you-go model, right? So let's say you own a business and you want to build your own data center for storage or processing or whatever. Let's say you're like JP Morgan and you want to do that. You have to go through the process of estimating the amount of resources you want to spend and you don't want to underestimate, because you wouldn't be able to do your work and handle requests and stuff. But you don't want to overestimate too much, because you'll end up paying too much and you can never go down. And this is kind of a big conundrum for large corporations. And so the advantage of cloud computing is that you pay as you go, right? So if you have some days where you have tons of traffic, it'll scale up to that. And some days where you have no traffic, you're not wasting money by having spent, you know, $1 million on a huge data center, right? This is like mostly practical in the sense that you really want to be careful when you're using AWS or something else, not to go over like the free tier limit unless you really want to. If you set up like an infinite loop somehow where your Lambda keeps running over and over again, like you'll have to pay lots of money, and that would suck. So just keep that in mind. Cool. So the other thing about cloud computing that we can cover real quick is basically the different levels of switching onto cloud computing, and also the different types of services that are offered, right? So at the lowest level, you have infrastructure as a service, okay? You can see in the triangle, like server, storage, network. It's very low level stuff. So you're talking about physical servers, network storage, and the data center, virtualization and stuff. Like that's what you have when you use infrastructure as a service. And there's certain AWS services that are perfect for that. I've mostly used like platform as a service and software as a service stuff. So like EC2 counts as platform. We'll talk about it in a second. So platform as a service is more like hosting a server with an OS on it and procuring that from your cloud provider. In this workshop, we won't use EC2, but it's really common. And we'll talk about it in a second. But that's like the most used AWS version of kind of, I guess, having a server to use at their center. And then system as a service, or sometimes application as a service, is kind of the highest level, right? And that's when you're basically, delivering an entire application to the customer. So, for example, there's some really good machine learning services like Comprehend or SageMaker or things like that at AWS that would qualify a system as a service, right? So you'll see it later. There's a big slide with all the AWS offerings on it, and these can all be classified under these 3 tiers for the most part. Cool. And also, let me see if I can get the chat up. If there are questions in the chat, I'll do my best to answer them, or somebody else can respond. But yeah. Right. So this is kind of how the different cloud computing competitors stand today. This is the main reason why we're just doing AWS, because it's a really good one to know. But if you're interested in cloud computing, it's really, it's fascinating to watch how it changes year to year and how different providers catch up. For example, like Google Cloud has like the lowest latency out of any of these now on average. And so it's possible that they shoot way up in the future and things like that. But it's really just good to learn one of these to begin with. And then it's not too different going from AWS to GCP or, what have you. So yeah, but these are kind of the big 3, if you can't tell. Cool. So that kind of finishes like the intro to cloud computing. Hopefully you have like a better idea of what it is if you didn't before. So now we'll talk about AWS, specifically how it's set up globally and like what you have to keep in mind with that when you're actually developing there, the services that it offers. And then I'll show like 2 simple examples of system design with AWS and go on a short rant about why I think we should have a cloud computing class here. So, so first of all, this is a map of all the different regions that AWS provides. So what you have to think about when we think of data centers as what you're actually paying to use is that they're obviously physical locations, right? And so if you have a data center in Iowa and you're trying to host something from China, it's just not going to be feasible, right? It's a terrible idea. So what Amazon and other cloud providers do, is they divide everything into different regions. So I believe there's 25 regions with AWS and over 80 actual data centers. And these availability zones is what they're called. Those are each a data center, right? And it's important to have multiple data centers per region for redundancy and things like that. Preferably. But I also think the CLI like version 1 would work too. I haven't tried it with the first one. So anyways, but yeah, like for example, if a data center just burnt down or something, which actually happened in Europe like 2 or 3 weeks ago. It wasn't an Amazon one, but it was kind of a big deal. You need to be able to replicate that across different storage centers. And also in terms of like, when you think about latency between places, like you want to be able to cache your information whenever possible if it's being frequently used. And so what Amazon does, and it's pretty complicated, but they'll try and cache stuff at the nearest data center to you. And then they'll also cache stuff, depending on the settings you choose, in different regions. If you're setting something up in one region and you want it to be available in different regions. Yeah, there's a whole lot you can go like into that rabbit hole, but we won't go like any further than that probably. So yeah. So this is kind of a listing of the huge offering that AWS has. And you know, it's pretty unlikely that anybody's used like all of these. Actually, it is possible, but there's only like, there's a lot of main ones that everybody uses, and there's some that are more niche, right? And I'll talk about some of the ones that I like personally. But you can see, obviously, they cover storage, data processing. I don't know, Internet of Things is really cool. There's actually more stuff here. They've got other things that aren't included in this. So like their machine learning stuff, I don't think it's here at all. They even have a service where you can mess around with a quantum computer. If you've ever done that or wanted to do that, you can do it for free. I'd highly recommend it. Just Google it. But yeah, obviously a lot of stuff. So in my opinion, and like in a lot of other people's opinions, these are kind of some of the main ones that you want to get familiar with. So we talked about EC2, and that's basically the most common way that you procure servers using AWS. And then the relational database service is like SQL. If you haven't taken databases, it just means it's a very structured database, and we'll leave it at that. S3 is basically cloud storage, so like static content. It's really easy to put it there. It's like, it might be the most used thing. I'm not really sure. It probably is. Dynamodb is what every intern at Amazon uses. It's a non-relational database, which just means it's less structured if you haven't taken databases. Virtual private cloud is a pain, and it's basically used to manage your AWS infrastructure and keep things separate from another for security purposes, kind of ensure like, you know, requests can't get mixed up and things like that. CloudFormation, which we'll use a little bit, I think, is basically setting up your AWS infrastructure as code. So you can actually write code that will create a Lambda or create a Dynamodb table. And you can also specify different settings on those and authorizations, and also how they communicate with each other if you're using like SQS, which is like the simple queue service, things like that. And then Lambda is like the GOAT. It's serverless event-driven code. So that means you're not paying for a server. You're only paying for when the Lambda is actually processing, and it's triggered by events, right? So like an API request, or if you have a messaging service set up where you're streaming data, for example, that's the only time Lambdas will go off. And then CloudWatch is just logs, but it's always good to like know logging before you go into industry. Otherwise, yeah, that can be an issue. And like, I'll send out the slides shortly, but you can go back and refer to this list and see their more formal definition for that stuff. Cool. Yeah, so briefly, I wanted to go into some examples of what system design in AWS looks like. It's kind of overwhelming to look at if it's your first time. But I think it's valuable just to have that kind of thinking of using AWS services as kind of Legos, right, to create the application that you're trying to create. So this top right one is an example of like an Internet of Things application. And I'm not going to explain fully both of these, but for example, these are different sensors. You're gathering data here, right? And you send it to AWS IoT, and then you use these two, I guess, messaging services. So SQS is simple queue service, right? So like if you were streaming temperature data once per minute, you can put it in a queue service, and it would actually make a line, then send it on to your processing application. And Kinesis is more like real-time data, like video or like things like that. Anyways, normally you would have like a step in between here where you process the data. So that could be with like Lambda or mostly Lambda, but I mean, you can put anything here where you actually take business logic on that data. And then this is examples. These are examples of storage solutions you can use with the Internet of Things application. And then you would report it back to like the client or whatever dashboard you're using. Uh-oh, I gotta mute somebody, sorry. Right, and so this other example is of a video game, basically. I'm not gonna go super far into this because there's a link in the slides that will tell you more, but this is a lot more what system design looks like when using AWS, maybe even like more detailed than this, to be honest. These are API gateways. These are probably EC2 instances. These are tables, obviously. I don't know. We talked about most of that stuff, but it's just good to think about. There's generally like a bunch of design patterns that you can have when you're designing to use AWS or like Azure or GCP or anything. And when you actually do this stuff, you'll get to learn those and it makes it a lot easier. So yeah, and also for my quick rant, there are colleges with like cloud computing classes and I think it's sick. I wish UF had one as a special topics course where you could get introduced to these topics and also like get experience with system design. So we're trying to convince the CISC curriculum board to like do that. We've mentioned it a few times, and if it happens, that'd be sick. It's obviously not in the spring, but maybe in the future. So if you see like cloud computing offered like next fall or something, remember us, okay? Yeah, cool. Okay, so that's basically all the cloud computing intro stuff that we wanted to cover. So we'll get started with the workshop. Let me see if I can send all these links again. And yeah, we should be able to finish hopefully. So this workshop is from a set of workshops that's really good. And this one is specifically about building a web app, a serverless web app for the first time, right? So what you should do is you should go to that first link and check out the instructions there. I guess I should share the instructions just to make it easier. But I'll broadly describe the steps and show you what it looks like on my end. I'll run through the ones that I can run through. I've kind of already done all this stuff before, but I don't know. I think I'll just run through the changes I did because it's going to be that way we can actually get through everything. But do your best to follow along, and if I go too fast, like just go to the recording or let me know. So yeah. And if you haven't set up the prereqs, it's no worries. Just come back to it. So just to cover like what we'll actually be doing, this is kind of the system diagram of what we're doing. And some of this might be new to you. I'll kind of explain it as we go along. But basically, we'll start by creating basically a Git repository, but on Amazon using code commit. And then we'll copy code from an S3 bucket that they provide. And S3 is just like static storage, right? So it's simple to copy it from. And then we'll deploy that website via Amplify, which Amplify is really cool, to be honest. I think it's actually somewhat new. So yeah, so we'll go ahead and get started. So if you go here, it'll tell you to log into the AWS Council and choose a region. I did North Virginia. I think the default's Ohio. And that's all fine and good. And by the way, this first step, when it says 15 minutes, that's cap. This first step is like the hardest. So I'm gonna go through it like somewhat briefly, but if it takes you a long time, like, I promise you the rest of it's pretty easy. So what you wanna do is once you're actually in Amazon, you have your account set up, everything, you wanna go to code commit and create a repository. So I already created my repository. I literally named it the exact same as the dude who made the tutorial. And I essentially just ran the commands that they provide in the instructions, right? If you haven't used Git before, I can show you like what that looks like. So like, I don't know, if you were gonna do, if you were gonna do, where are the instructions at? Yeah, if you were already in code commit, you could basically clone from there. So you'd have to copy like the URL, and then you would do git clone, whatever this is. Well, I already did it, but you get the idea, okay? And hopefully, like, if you haven't used Git before, it's cool. Just like go along with the flow. We'll have like another workshop for Git in the future. But it's a version management system and stuff. So yeah. What else did I want to cover from this step? So code commit is the repos. It's the same thing as GitHub. It's just makes things a lot easier. I know in the instructions it says you can use GitHub or code commit, but I'd highly recommend using code commit because otherwise it gets things complicated like in the later in the process. IAM is really annoying. So I do want to show you this in case you have issues with IAM. So what you want to do, and this might actually be the first step, is you want to create a user. So you would go to IAM, you go to user, and you make a user. And that's all fine and good. But just make sure to give it administrator access or else nothing you do will work. Okay. So like policies and authorizations are really important for everything you use in Amazon on AWS. And you kind of have to make a policy for everything. So just remember that, like whenever you're creating something new, make sure to check the policies. Otherwise you might have issues. Cool. So let's see, you would create your repository, you just follow these things. And then this username and password is straight from when you create that role that I just showed you. I'm not going to show you mine because then you could like mess with my stuff. So yeah. And then the next step is actually copying from S3. Remove this slash because I don't know. I think this is a typo, but you don't need it actually. You basically go in the repo and copy from S3 from their link. It's pretty simple. And I can just show you like this is all the code you're getting from it. And then if you've never used Git before, just follow these steps exactly. And if you have used Git before, you probably figure this out. Cool. So at that point, like hopefully you have the repo set up by now, or like you're getting there. And the next part's really, really simple. So what you want to do is you want to go to Amplify. Why did it not take me to Amplify? And normally you would click, I think there's like a create a new app button. I think it's this one. You create a new app, you give it the same name, and you would just yeah, I think you can just, yeah, it just goes to your code commit. That's what it was. It used to be that this tutorial used S3 only and not code commit. So I'm kind of like new to that. But yeah, so when you actually do that, you'll kind of see this continuous deployment pipeline, which is pretty cool. If you haven't used like continuous deployment before, it's basically whenever you push changes to your code, it'll just automatically go through the build process and then actually deploy it on the net so you can check it out. And yeah, so that's basically the process. And then what you do is you can click on here and see what it actually looks like. It's got a very strange name, but you know, it's actually a pretty good example. And if you've never created a website before and you follow these steps, that's technically your first time creating a website. So congratulations. Yeah. And feel free like to check out the code or something if you wanted to figure out how they actually built this like at the low level. So cool. And then what they want you to do is modify. So like this is it's just to show that the continuous deployment is working. So like, for example, if I remove this change for demonstration thing, you would see that the title of the website would change. I'm gonna call it change. And then in like shortly, if I went back, you'll see this says dash change for whatever, and it'll just remove that. So it might take some time though. You can watch it build live in the Amplify console. Cool. And that's basically it in the first module. So that could be your first time hosting a website. That's cool. The second part is all about basically managing users. So one functionality of this demo site is having a login, right? And so there's a lot of applications obviously to having a login. If you have a mobile app, you want to have somebody log in, you can use Cognitive to do that. It also integrates with like Facebook or Instagram when you want it to. So Cognito is pretty good for that as well. Yeah, it's just a useful thing to have. If you're at a hackathon and you want to make your website or whatever you're building look more polished and want to add a sign-on, you can just follow these steps. It's like relatively quick and just use some of the code from this example. Right, so I'll go from the top, I guess. So what you want to do, this part is probably the fastest. How did I get out of this? Oh yeah, you want to go to Cognito, manage user pools, and normally you would create a new one, and you would create it with basically the exact specifications that it says, the defaults, things like that. And I wouldn't just keep the names the same, otherwise it gets confusing. Yeah. And then once you do that, you want to add the app client. So the way you do that, if I remember correctly, you can go to app clients here, and you would add the app client ID. Now you guys all have my app client ID if you want to add it to your pool, I guess. And it'll tell you how to grab that, I believe. I think you can actually just search for it and it'll come up. Oh yeah, it just generates it though. And then what you want to do is actually go back into your code and edit the config. So this is what's cool about like continuous deployment. You see how that like removed, you can see that our continuous deployment is working. Like being able to manage, I guess, the infrastructure of your code. So we're adding like Cognito, a sign-in functionality to this website. It's super easy to do just using code. So I believe it's in the JS directory, nano config, and then you guys can steal this stuff if you want, I guess, I don't care. But what you would do is you would add the user pool ID that you just created and the user pool client ID that's also generated when you add it to the user app. So this is like the second thing, just to be clear. And then the user pool ID, I think it tells you how to find it, but it's like, I don't know, it's somewhere in here. App client settings. Is it that? I don't know. It's one of those two. It says like in here specifically. Full details the Amazon Cognito after. Okay, so you get it after you create it. So make sure to copy that down somewhere. If you're like me and use US East 1, just remember to put it there. And then you leave the invoke URL gone for now. Right? And then once you go through that process, you can finish up and then basically test your changes. So what you do is you go to your app link, whatever it's called, and go to register, and you'll see a space to put in your email and password. So you can go ahead and do that, and it'll actually send you an email. And you actually have to go to your email and verify it. I'd recommend using real email because, I mean, you don't have to if you don't want to, but then you have to go manually in the council and approve it, and it's kind of annoying. So yeah. So once you get to this point, go through, sign in and make a password, and that'll kind of get you up to speed. And then it'll tell you basically to go to here, and you go to users and groups, and it'll show you the account that you just created. And if it's not confirmed, you want to click on it and confirm it. But if you use a real email and like put in the two-factor verification or whatever, then it'll work. Cool. Yeah. Okay, so I think that's it for module 2. Besides, let's see. Oh yeah, you can go to verify right now, but it won't really be useful. So yeah, so step 3 is actually creating the infrastructure of the backend, right? So this might be a little confusing, so I tried to put this down here if you haven't done this before. But so far, we've basically finished these first 2 steps, right? Pretend this is code commit. And then the second step was creating this Cognito user pool for people to log in. So now what we're actually going to do is put in backend logic and storage for our website. So first you create a Dynamodb table. This is like the simplest Dynamodb table possible. It only stores write IDs. and you're only creating a Lambda function that can put items to it, it can't actually like read anything from it. And then the Lambda function itself, we talked about it, but that's serverless event-driven code. So whenever you send an API request to your website, which we'll build shortly, your Lambda will be triggered and then write to that table with the right ID that was generated via the Lambda. Right, so that might not have made a lot of sense, so we'll actually like go through what you're doing. So back in the console, you want to go to DynamoDB. This is like the NoSQL database that doesn't have structure. I hate DynamoDB, but I've had to use it every time I've ever done anything with AWS, so there's that. I already made the table, but it's pretty simple to do. Like you just enter a name, put the partition key, and don't put a sort key. Default settings, and that's literally it. Yeah, and you can see right now mine already has some items. There should. Hello? I don't know. Yeah, you can see like it's got one item in there already. Yeah, so that's all you do. So you create the table. That's pretty easy. And then the annoying part is going back to IAM and making a role for Lambda. I can kind of run through it, but like IAM is always the most time-consuming thing in the world. So we'll just do our best. So what you do is you create a new role, and you can call it like Wild Rides Lambda, but whatever you want, it doesn't matter. And then you're going to make this policy name. So what you're really doing with this is you'll add an inline policy. You will put on DynamoDB write access only. That's all you need. And then you can name it, or you can name it AWS Lambda basic execution. And that's it in that step. Right. So now you've created a role, you've created your table. And oh yeah, they also want you to specify the ARN of the table itself. You can find that just by going back to DynamoDB and going to your table, and like it'll have the ARN, you can copy paste it. If you're really lazy and you intend to delete the stuff later, you can just give it access to like all your tables. You know, it's your choice, I guess. It's a bad decision, but like if you're lazy, you can go ahead and do that. So yeah, so now you actually create the Lambda function. So this is the exciting part, right? Like we're actually going to create code that has business logic and does things for us. So you would go to Lambda. The version of Node they mentioned in this tutorial is outdated, so ignore it. You create the function, call it whatever you want. You can use 14. You could also use 12. It doesn't really matter. I use 14. It's going to work. Don't change anything else except for default execution role. Use an existing role and then choose the role that you just made earlier for the Lambda. So what this role does is it just lets your Lambda write to the DynamoDB table, right? That's literally it. Otherwise, you'll get like 403s and it's annoying. So yeah. And then no advanced settings, and then you would just create that. And then once you create it, you'll be taken to this beautiful page. So you don't have to worry about like going through the process of coding all this because they've done it for you. But they've also like left meaningful comments. It's really easy to understand what they're doing here. Just given like the time constraints, I'm not going to go like super hard into it, but just read the comments and they'll explain it all to you. But what you would do is you would copy that from that link, this request unicorn, and you can actually edit it live in your function. So I just like Control A, Control V, whatever. And then you want to do file, save, and deploy. And so now you've created a Lambda that can actually do stuff, which is cool. And then what's fun now is you can actually test it. So this is when you actually start to see your things work. So normally what you do is you configure a test event. You would press that button, create new test, give it you know, a name. Normally you wouldn't have this template there. And then you can just copy and paste the JSON request here into there. And then once you actually run it, you should see 201 and a body of JSON that actually makes sense. So it gives you the right ID, the name of your unicorn, the color of your unicorn, gender, etc. Very exciting. So yeah. And that's the end of module 3, right? So we've created a website now. We've made a sign-in function to it, and we've created a backend. But right now, there's like really no way for anyone to interface with that backend because the Lambda is not hooked up to anything, right? So if we go back to our architecture here, we're missing this API gateway that would invoke the Lambda. Now, what the heck is API gateway, you ask? Well, if you're like a freshman or a sophomore maybe, and you haven't heard what an API is, application programming interface, it's like what the internet is built on. So basically, if you ever write code that does stuff, you want to be able to access that code. So having an API is just basically a way for software to call your software, right? And obviously, like Square, for example, you've probably heard of their API for financial stuff. Google Calendar API, that's a thing. And the way APIs work is you send a request and then you get a response, right? And that's really all it is. That's kind of like the interface that's there. That's like in layman's terms. So yeah, but in this step, we'll actually create an API, and like hopefully you might not do it a lot in class, but hopefully like by the time you've gone through an internship or two, you've created like tons of APIs and you'll be a pro at it. And it's like kind of the bulk of what you do when you get into industry for a lot of people, not everybody. But it's good to like have this exposure now if you're young. So you create an API and API gateway. What we'll do is we'll use that Cognito pool that we had before as an authorizer, meaning that only people that are in that Cognito pool and authorized by Cognito can actually invoke our API and get our Lambda to actually process and write to the Dynamodb table and give us our unicorn. So we link it to our Lambda, and then we have to update the configuration of the code in our repo to add the invoke link, basically. That was kind of a lot of words. So it'll make more sense like when we actually do this, I think. So you would go to API gateway, and normally you wouldn't see this stuff here. I can show you what like creating a new one is like. I would just do REST, but I think it'll actually work with that. And they tell you to keep all these settings except change the endpoint to edge optimized. So like mainly the only time like you would do regional is like if you only want people to access your stuff in the same region. So edge optimized is like cool. It uses edge caching, which is a concept we talked about like very briefly. But basically you would go ahead, create your API, blah, blah, blah. And then what you want to do is actually add Cognito as an authorizer. So I believe where that is I think you have to create ride, or I don't know, did they make you make the post first? Yeah, it's right here. So what they do is they make you make /ride and add the post method to it. If you haven't like studied APIs or like know a lot about what they do, that might be a good topic for like a future workshop. But yeah, for right now, just follow the instructions, and I can provide you like with links in Slack more for you to read up on. Let's see. So you create your /ride. I thought you would do that first, maybe not. I mean, it's going to work either way. You can just do /ride first. You click on method request and add WildRide as an authorizer, and you would add the ARN of your Lambda. And it should be good. Yeah. So now, if you go here, in theory, when you go to ride, things will happen. So you'll get a map. And basically, like the point of this map is for you to request your unicorn wherever you are. I don't know where this is at right now. I want to give us a unicorn like in Gainesville. Yeah, so you would click here, request unicorn or whatever, and your unicorn flies in, right? So now, in theory, things should work. Oh, I might have skipped some steps here. Let's see, did I add? Yeah, you add the Lambda function to the post method itself. Make sure you're using the correct region, by the way, otherwise it won't pick it up. Yeah, that's all you need to do, really. So, oh yeah, and before it actually works, what you have to do is deploy it. So you go to Actions and Deploy, and you create a new stage and call it whatever, but I already made one, so you just call it prod, and then you deploy it. Yeah, it's that easy, really. And then the invoke URL, this is what you copy into your, man, I did skip a lot of steps. You copy this into your config. So, sorry, I'm kind of thinking ahead. So what you would do is you would go back to your repo, and you would go back to this config file that we just opened. And then you add, in the invoke URL, you add the URL that we just copied. I'm not gonna like, I don't know. You can see I copied it, it's whatever. Yeah. And then what you do is you git add everything, and you git commit, and a message should be like add API invocation or something, and then you would git push, but I haven't changed anything. So yeah, and then what would happen is you would go through the pipeline on Amplify. It'll show you the pipeline. After like a minute or two, you can refresh, then everything would be working. Cool. Yeah, so that was creating your first API or your 100th API, depending on, you know, what skill level you're at, I guess. But yeah, and then the 5th module is to get rid of everything. So obviously you should do that, especially if you kind of cheated, like I mentioned, and didn't actually use ARNs and gave access to like all your tables. Because if you want to use this AWS account in the future, like it's just bad protocol to give anything access to all your resources. So yeah, let's see. So by now you've created this whole thing. So we went through Amplify for developing and deploying your service, Cognito for authentication and user pools, API Gateway for creating the actual API methods, and Lambda for processing data, and Dynamodb for storing data. And overall, I think that's a pretty good intro to what AWS can do for you. We did all this in like 30 minutes or 45 minutes, I guess you count the beginning. So it's pretty cool. Awesome. So if anybody has questions, by the way, let me know, since we went through that like pretty fast. I probably went a little bit too speedy, but if there's questions, I can always hit up the Slack chat later. No worries. So the next steps after this workshop, I think we've kind of already emphasized how cloud computing is used in industry, and it's basically used at like every major company in some way. So it's like obviously very valuable to learn. What I would recommend is first looking at the entire repo of workshops that kind of extend from this. This was made by like a solutions architect too, by the way, who gets paid a lot more than I do to to make good workshops. So these are all like pretty quality. So we just basically did this one. The ones that I would recommend is the DevOps one and the event-driven architecture one. They're all like good, and depending on your interests, for example, like machine learning sounds cool and stuff, maybe you want to do that. But doing those two really gives you a good idea of like AWS infrastructure as a whole. This one gives you experience with continuous integration and continuous development some more, which is like used at like every company. And event-driven architecture is something you won't cover very much in school, but it's used across industry, right? And using simple notification service or SQS, simple queue service, is super valuable if you are planning on using AWS at any internship. Like I guarantee you'll use it. So yeah, and then if you want to get certified, we'll talk more about certifications in like 1 second. But in my opinion, A Cloud Guru is the best thing. You do get a big discount, but it's still expensive, which is super annoying. And I couldn't find a way to get it for free. Normally, like I can find a way, but not this time. But we also get LinkedIn Learning for free as UF students, or Lambda, whatever you want to call it. And that has really good courses on AWS, and you can represent it to recruiters that way. So that might be a better option. Also, we didn't do a whole lot of coding during this workshop because I kind of just wanted to cover actual like cloud infrastructure more than anything. But basically everything we did in this workshop when we were in the console and things like that, you could have done without ever looking out the console. You could have done it programmatically by setting things up in your code to do it for you and committing to that repository. So like all those buttons that we clicked, there's ways where we wouldn't have to do any of that. And I think that's pretty cool. Sometimes it takes longer, but it's something cool. So what you should do is check out the SDKs, maybe look up some example applications. I know that repo that we linked has some, but if you're interested in building a specific thing, maybe you want to try and do an AR application with like Oculus Rift at your next hackathon and use AWS. There's like really good example repos out there doing that exact thing. So I'd recommend going through the documentation of whatever language you choose. I've done a lot in Java and Kotlin, and that's like mostly what people use, I think. But Node is like popular as well. And then also just looking up on GitHub for your own resources. Yeah, cool. So we talked about getting actually certified. And if you were at our second GBM with Accenture, which was, I think, last week, right? Maybe 2 weeks ago. They talked a lot about how getting AWS certified in industry can lead to like significant pay bumps. And there's people that attribute their career success to getting AWS certified and stuff, right? And so in terms of like the progression for AWS certifications, the first one you want to get is the cloud practitioner one. It's supposed to signify 6 months of experience. That's cap. You can do this in like 2 weekends if you grind it and take the test, and you can get the cloud practitioner certification. And that by itself is like a lot more than what most college students have. So, if you're aiming for an internship at a specific company and they use AWS, maybe it's a good idea to add that to your repertoire and your resume or LinkedIn and let them know in the interview, and then from there you can go through these different paths. There's actually a couple more than this now too. But the associate's the first level, and that's generally what people focus on when they first get into industry. And then professional is like you've been, I don't know, you've probably been at it for like a year or more of actually professionally developing in AWS. So yeah, and there are more certifications than this, but this graphic was the easiest one I could find. So yeah, I think if you were here last time, a couple of people from Accenture said they had 4. I think one person said he was working on like 6 or 7. So it's really cool to get ahead and try and do that. Yeah, cool. And that's basically it. So if you have any questions, once again, send them in the Slack channel that we made. Yeah, in terms of like future